here I have 3 data sets. I think not 3, I think around 5 data sets. So I have, I don't know whether we are going to use all of them, but let's take a look. So we have this one on airmen. That's got from Tidy Tuesday. Tuskegee Airmen. I don't think we are going to use this one. Let's not even discuss that. I think it's not important for us right now. There is another data set on breeds of dogs. So here we have the breed of the dog and the traits of that dog. Whether that dog is affectionate with the family, good with young children, good with other dogs. It is given a score. Maybe I think this is a score of up to 5. So there is this dog called Retriever, Labrador, whether it has a shedding level, coat grooming frequency, how frequently it grooms itself, drooling level, I don't know what that is. The coat type, its coat, the coat length, openness to strangers, playfulness level, a watchdog protective nature, adaptability level, and trainability level, energy level, backing level, and finally we have mental stimulation needs. So this is a breed of the dog. So that's one of the data sets. There's another one on chocolate. So here we have the company, the location of that company that processed that chocolate. Here is the country of bean origin. So here we see Tanzania, Dominican Republic, Fiji, Madagascar, Uganda. So where that bean come from that create that chocolate. And maybe what is important, the cocoa percent, the percent of cocoa in that chocolate, and the most memorable characteristics, rich, cocoa, fatty, bready, how they feel, how someone feels chewy, or rubbery, fatty, and then the rating. People are given an option to rate that chocolate, 3.25, 3.5, just rate and some other. And in here we have a column for the ingredients. These are the ingredients. Okay, let's look at something. There's also another one, another data set for a client I've been working with. And here we have, this person was trying to see whether people are organic farmers or they are just chemical farmers, the one that use pesticides. They use for cabbages. So for now here, this data was taken in Kenya. The crop that we're looking for is cabbage or kales. The county is Murang'a. The sub-county is Keumo. Ward is Kangare, sub-location, the village, and all those things. So these are typical data sets that anyone can come up with. Name of the farmer, household gender, household head gender, the education level of that person, the marital status, the number of the farming years that farmer has been farming, the household size. Then there was, besides crops, do you keep livestock? They say yes or no. Livestock type they keep, what kind of livestock they keep, and all those things. Do they sell their vegetables? Do they spray their vegetables? And all those things. So those are our 3 data sets. And we're going to do just a few tasks to see what we can come up with. And last time we talked about pivoting data, pivoting wider and longer. And I think the only thing we did is pivoting longer. So I would like us to see whether we can be able to pivot wider. Let's look at this code type. So let's select these 2, the breed and the code type. All right. So let's take that data, breed traits, and then let us select the breed and the code type. So we have these 2 data sets. The breed, just if only. So we've taken this breed traits, this data set. This is a data set. And then we have selected these two columns. Okay. And then let us select another column, which is, that's on preference. Let's try another one. Let's try another one. Let's look at, what can you look for the dogs? Energy level. Let's do, or the barking level. Let's see which dogs barks most. The barking level. Let's take another thing. Barking level. So we have chosen those three: the breed of the dog, the coat type, and the barking level. Okay. All right. And then let's choose just a few of these. Just let's take from number 1 to 10. So let's look for a criteria that we can use, or let's just pick a few dogs. So let's filter. Let's just pick a few dogs and say breed is anything that is in is. So let's pick this first one. This one. Let's copy that. Okay. Let's be the French bulldogs. Copy that. Just a few of the dogs. Let's another one. This is the German Shepherd dogs. Let's pick bulldogs. Copy. I don't know anything about dogs, so that's what I can tell you about these things. These are they are calling poodles. Poodles. I don't know. There is the famous one here. I hear about called the Chihuahuas. Let me see whether I'll find them here. So breed traits. Let me just see what I can get there. There's so many. I don't think I can be able to see Chihuahuas. There must be somewhere in here. Anyway, I don't know. Let's pick this one just for the sake of it. Let's look at the chocolate, see whether it's okay. Chocolate works. Okay, let's see whether this will work. Now let us filter. Let's see whether this filter will work. Filter this company location. Company location is equals to US.A. Let's see what is no. Dot and here. Press this works. So we have all the companies from the US only. Okay. This one is working. Chocolate. So we are looking at the chocolates. So we have data from US. Company location is US there. Let's look at the cocoa percent, the percent of cocoa. That is percent cocoa and rating. Okay. So let us select cocoa percent rating. Good. And also company location is important. Company location. All right, let's work with this. So we have the US. Let's pick some few countries. So let's put France. Let's see how it is written. Avoid issues. So let's see. France. So France. And let's pick another one. Fiji. Okay. France. And then Fiji. Sorry, it should be. So we have USA, France, and Fiji. Now, this data, as you can look, if you look at it, it is in what you call, it is long, it is not wide. It is in long format and not in wide format. Now, I would like maybe to have these names of these three countries on top here, and then the percentages below here, and the rates just where they are. That's what we call pivoting wider. And what we just say pivoting, pivot wider in this case. And we say where we want our names to be from. And our names are from the company location. Company location. That's where we want these names to be the columns. And then values, we want the values to come from the cocoa percent. Cocoa percent. Let's run that. Okay, there is an issue. It is not uniquely identified. So we need to add something. Yeah, say mutate. Let's give them a rank. Let's give that rank to be equal to the row number. Row number. If you do that, you've given it a rank, which is the row number. So the one that is row number 1, it is given the rank number 1, just to uniquely identify those levels. So we have said mutate rank. We've created a variable called rank, and using the row number to say that that's what we want. And here it is. So we have the rating still remains the way it is. We still have our rank there. And so we have US is here on top now. France is here on top, followed by Fiji. So, and you can see that the rank for US, it is 76%, almost in this case. For Fiji, and the rating is 3.25. And for France, here the rating is 70%. So we have removed this row to be from row names or row inputs to be columns. So that is what we call pivoting wider. And that is really done. What we mostly do is pivoting longer. So that was that. That's what I just wanted to repeat according to that. And I would like to go to something else. Now, there is what we call the grammar. There are two things in R called the grammar of graphics and grammar. I think grammar should be like that. Grammar of tables. Now, when you talk about grammar, you know grammar, what you call in Kiswahili lugha, is the way words are arranged to form a sentence, and then to a paragraph, and then to maybe a prose. So grammar is the way words in English, for example, in English, is the way words are arranged to make a sentence and make that sentence make sense. So they have to be a subject, they have to be a noun, and they have to be a verb. and maybe helping verbs and conjunctions and all those things. So when it comes now to graphics, when you want to do visualization, there is a way of doing, there's a language or a grammar or a way of doing it, and it is constant. And then when it comes to tables, then we have a graph of, we have grammar of tables, the way of working with tables. And today I want us to start with the grammar of tables because it's simple and it is not a lot. And in this grammar of tables, there are around, so there are so many packages that can be used for in the grammar of tables, but one we have is GT, which is the grammar of tables. GT means grammar of tables, that package for GT. And then there is another package called GT extras. So this is also for tables. And also they have another one called GT summary. And these packages are quite complex, but we'll start with this one because it is simpler, and then maybe later on, on your own, you can look at the GT extras. And what is maybe most important, maybe the GT, but what you need to know most is GT summary that gives summary tables for what you want to do. And for that, I would like to start with this data set called final edges. So in this data set, we have so many variables, but I want just to pick some of them. And in this case, I want to pick the social demographic factors, and these include the gender, HH gender, the gender of the household head, the education level of this person, the marital status, and the farming years. So let me pick those. So this is final edges. So I just want to select those variables. Select, I want to select HH, head, gender, education level. I want to seek marital status. Let me see what else you said we pick. Farming years, the number of years this person has been farming. Farming years. Farming years, maybe also farming method. So let's select those. So we have them here. So we have the household gender, the education level, the marital status, the farming years, and the farming method. So we would like to know how many males are there and how many females are there. How many are in primary school, only go to primary school? How many are in upper or senior secondary? How many have no formal education, and what is their percentage? The frequencies, that is how many they are, and the percentage they take. So in this GT summary package, there is a function called table summary. Table summary, just this TBL summary. And what you just need to do is to and then add that here, table summary. So the second one. And if you just run that, you see that it will develop a very nice table. Let's see how it looks. Give it a minute. Here it is. So we have the characteristics or the variables. So we have the household gender. It has given us that there are 8 females and they take up 20%. We have 33 males and they take up 80%. So, and this is the total number of our respondents, 41. So the people interviewed, the respondents were 41. So of the 41 respondents, 8 were female, and this made up 20%. And now that 3 were males, which made up 80%. So see, this has really simplified our work that you would have done so many calculations. When it comes to education level, so those without formal education were only 2, which made up 4.9%. Primary school, we went only to primary school, there were 18, and this is 44%. So this is 18 of 41. Up to junior secondary, only 3 of 41, making 7.3%. Up to senior secondary, only 12, which makes 29%. So the majority here, we can see, only reached primary school, which is 44%. Marital status, most are married. 88%, 36 out of 41. So farming years, so most have been farming for more, this is more than 10 years. So 95%, 39 out of 41. So as you can see, it has given us a very good breakdown of those variables. And we can do something else. Let's just copy this. This will come in handy. And then we say, we want to see how they were distributed over the farming methods. We have 3 farming methods. We have conventional farming method. We have a mixture of both conventional and organic. And we can see most people are under a mixture of both, which makes up 37%. But they were somehow balanced in the 3 farming methods. So we want to group them by, you see by here, group them by the farming method. Just say the farming method. Farming method. Just that. Let's see what happens. Good. Now we have a new table. That's how it looks. Now here we have it categorized according to the farming methods. So females, you can see their percentage under conventional, their percentage under mixture. So most of them are here and here. So this one does a very good breakdown. And this table is very easy to use and put in your Word document for presentation or PDF or anything. So as you can see, now it has broken down in the 3 groups that you have divided them by. This comes in very handy and really makes your work very easy. So farming years, so 15 are under conventional, 15 of the 15. So you can see here, 15 people are doing a mixture of conventional and organic. And all of them here have worked for 10 years, have really done farming for 10 years. And only 13 people of the 41 are doing organic farming. And all of them here have been farming for more than 10 years. So, and in here, 13 people of the 41 are under conventional farming. They do conventional farming. And you can see that 69% of them here have gone to up to primary school level. So that does a very good job. So, and then there are so many other things you can add. You can say you want to add a p-value, and a p-value, this is a statistical, when you're doing a statistical test. And as you can see, this is categoricals, these are categorical variables, and also these are categorical. So the test that can happen here, we'll discuss this later, but the test that is appropriate here is a chi-square test. A chi-square test of independence or association. And if you put add p, let's see what it does for us. So it gives us a p-value. We don't have to calculate a p-value on our own. Let's see how it does it. So we have a p-value for each and every one of these. So we have 2 levels here, and it is tells us what test it has done. So Fisher's exact test. So this is an unparametric equivalent of the chi-square test. So it tells us that this data is not normally distributed, and therefore it has opted for a non-parametric statistical test. So 0.4, this is greater than 0.5. So this tells us there is no association between conventional, any of the farming methods, and the gender. In here, this is less than 0.05. So this tells us that yes, there is an association between your education level and the farming method that you employ. Marital status, this is greater than 0.05. So this tells us that there is no association between the marital, whether person is married, divorced, or whatever, and the farming method that they employ. This also tells us this is greater than 0.05, so there is no association. So when it comes to the test of association, the null hypothesis, when using the 0.05 level, whenever it is greater than 0.05, we say that there is no association. If it is less than that, then there is an association. Those are things that we're going to discuss later. So here it says that the education level that a person affects or influences has an association with the method of farming that they employ. So we can have the p-value. So this is a very simple way of analyzing the data. So in that case, we only took the categorical variables, the one that have labels, the characters. What if we picked, let's say, final values? Let us select the variables that are continuous, the one that are numbers, real numbers, household size, how many people they are there. So HH size. Let's look if there is anything else that can be picked that is continuous. Don't seem to have any other. So let's go to maybe chocolate ratings. There is anything. So let's look at the rating here. So let's pick. So chocolate. And then let us select the rating variable that is continuous. It is a number, it is numerical. And then let's tell it we want to table, we're going to get a table summary of that. Let's see what it gets us. So it gets the rating and it gives us the median. So this is the median and the interquartile range. So this is the lower, the first quartile, or the 25th percentile, and this is the 75th percentile, or the upper quartile. So the rating, the median of the rating is 3.25, and these things are things that we can change. Those are things that we can change. And the way we can change them, I don't know whether I should do this or not, but this is what you could do. Just say statistic. What statistic do you want to use? Statistic. And say it is the rating that you want to get the statistic. Then use a tilde. This is you use shift and the very first key before number 1. Tilde. What you want to, you can, then you put quotation marks, and then in there you put these curly brackets and write the function that you want. Maybe let me see whether that works. Yes, so we have the mean. So the mean of the rating is 3.20. You can put, let's put also outside it, but within those brackets, let's put the standard deviation as D. So if you put it into brackets as D. Oh, sorry, I must put the curly brackets. I'll explain later why we put the curly brackets, something else. But you just do it and it will give you whatever you're looking for. So we have the mean is, and it has told us here that this is the mean. What we're having is the mean, and what we have in brackets is the standard deviation. Let's look at something. Let's look at the breeds of these dogs. Let's look. How to clean this data? Oh. Sorry. This is a breed straight. So don't worry about this command. I'm just trying to clean the name, so I'll explain this as you go on. Janitor. Let us clean those names. Now let's look how breed traits look like. Yeah, they are the breeds affectionate to the family. So let's pick that. Also, breed traits, that is the data set. I want us to select the first column. Let's go all the way to, there's so many, you can do all of them. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, around 10, up to column number 10. Let's see how they look like. Okay, so let's add that table. So let's get the summary of that, see how it looks like. Okay, so it has done a lot, but it's giving us the defaults. So there are so many breeds. Oh, I made a mistake. There are so many breeds. So it is giving us, so most of them are 1, 1, 1, so each one was 0.05%. So affectionate to the family. So all this is a ranking, it's 1 to 5. So affection with the family, most of them were affectionate to 68% affectionate with the family. Good with young children, most of them were. So that's where I think we should filter some of these things. Breed to be some of these. Let's put it get unique breed traits. Cut the breeds. Let's try this. Copy. Oops. It should be there. So that will work. Yes, logos. Okay, okay. Let's try this also. Copy this. But remember, you have to put to concatenate here. That there. And then here, because there are more than one, say everything. So should be that. Okay. So you've chosen these two. Okay. Let's put our summary there. Let's see how summary works. So we've just taken the grids, filtered these two grids. Let's see how they are. Okay, okay. Okay, but instead of having that, let's say by is equals to the breed. Let's see what it gives us. All right. Let's have this. So, affectionate with the family. So this breed has a rank of 3. It is ranked number 3. And this one, so that means that this logis is more affectionate because it gets a rank of 4 more than this, which is given rank of 3. So 100%, 1%. Good with young children, both get a rank of number 3. Good with the other dogs, both get a rank of number 3. Shading level.